Hi everyone, I'm Ben and welcome to the second episode of the Sauropod Studio video podcast. Just before we begin, I want to thank you guys for the great comment we had on the first show. I hope you enjoyed this new platform. The team and I are very pleased. And also, the Castle Story roadmap we talked to you about on the last episode is now online. You can go to roadmap.castlestory.net. It's available. You can follow all the steps of development of the Castle Story game right on your desktop, laptop, whatever you're using, your browser, your internet browser. So Cal Hall on the last show asked in the comment section on YouTube if we could show a little bit more of the artistic development of the project. So we're gonna go see Germain. He's gonna talk about how he's using the shaders in the Castle Story game. So, we're gonna go see Germain. He's the head of the artistic department here at the studio. He's one of the co-founders. We'll try to have a chat with him. So, let's see what happens. So, Germain, you have a few minutes for us?
Yeah, sure. Yeah.
Cool. So, what you gonna show us today, Germain?
I'm gonna show you shaders.
What's a shader?
So basically shaders are like little bits of code that the graphics card runs. It's like programming, but instead of for the CPU, it's for the GPU. Mostly graphics. Obviously you can do other stuff with shaders, like we call them compute shaders. It's complicated stuff, but it's mostly for graphics. Yeah. So geometry, texturing, stuff like that. Yeah.
You know how much shaders there are in Castle Story right now?
No.
We'll cut that out.
But there's a lot of versions of each shader. Basically, if we find a more optimized way of making a certain material, we're gonna keep the old shader to ensure compatibility. I'm not sure I should be showing you like the big complicated. That's not even the most complicated shaders. I'm using a tool a visual tool to make shaders, but usually shaders are written in code. There's a really awesome tool that came out for Asset Store called Shader Forge, and it allows you to program shaders visually instead of having to. So yeah, basically like every single box is like a mathematical expression. And
so it is the code, but in a visual.
Yeah, sort of. I could find an old shader. Okay, so basically like this is a shader that is normally written in plain code. So you can see that it's really short. There's not a lot of stuff, but it's really compressed. So it's hard to read and it's hard to write because you need to. There's not a lot of documentation, to
know to interpret them.
Yeah, exactly, or to even know what to write, right? And so shaders, it's like an in between programming and graphics artists. So it's hard to find people that know how to write shaders. So luckily, this tool came out that allows non-programmers to if they have the knowledge, they don't need to know how to write it as long as they know what to do. Shaders, like what they do is that they it's pieces of code that lets you interpret, like for every pixel that hits this surface, what's gonna happen, right? So you take in account like ambient lighting, nearby lights. You can put textures on the material. A material is the surface of an object. So like the most basic shader would be to you put a color, you plug it into the diffuse. Diffuse is like the surface color of the material. So in this case, I could change it to any color, and so then you have a shader that just outputs a single color. and it responds to light because most shaders by default do. But you could also just not respond to light at all, or yeah. So, but then there's a few things you can do to make more complex shaders. You could, for example, have a specular value. A specular value is the reflection of the light on the surface, so it gives you like more shiny objects, and then you can also put what's called a normal map. Normal map is like normal maps are basically like a way to bounce the light differently. Like it gives this false surface detail that is not
the false sense of deep. I don't know, say deepness, but
yeah, depth.
you know, depth. Yeah, yeah.
It's like this this detail on the surface that is not actually there. It's just it's not in the geometry. It's in the texture instead.
Like for example, the current Corruptron design we have in the game.
Yeah. For example, like the Corruptron in the game is very simple in terms of geometry, but we put a normal map on him to give the illusion of more detail, because it's cheap. It's like a optimization trick. So yeah, for example, now I plugged in a normal map on the texture, so you see it's still the same sphere, but now I put in a detailed texture on, and you see the specular light is a lot more interesting. It's a lot more detail. So it's a really simple trick to add more detail than it should actually have. Another trick I could do is just plug in the normal direction, for example, and then the normal is the direction perpendicular to the surface, like in this picture, for example, and then using that normal direction, interpolate between two colors. So so it's world normals. So if it points directly up, is going to be one value. If it points directly down, is going to be another value, and these are going to be interpolated between 0 and 1. So I could have, for example, two colors. I give this one red, for example, and then this one is blue. And then if I plug these. This is all stuff you could do in with code. It's just that now it's really visual, so it's really easy to follow. So
convenient interface.
Yeah. Actually, I'm really impressed by this tool. I really recommend it to anyone who wants to mess with Unity, and also is interested in graphics programming. This is really useful tool, because you don't need two people, an artist and a programmer to make the actual shaders. If I plug the result in the diffuse shader, you can see that so it points in one direction, it's more red. If it points in another direction, it's more blue-ish. Yeah, and so with all these sort of tricks you can do, there's a lot more. There's like an infinite possibilities. I could, for example, open an existing shader. I did the gradient shader. Oh, that was the one that was loaded before you arrived. It's gonna take a few seconds to open. But for example, I actually have that trick I just showed you. Like if it points up, it's one color. If it points down, it's another color.
In this particular case, what is this shader is used for? What?
Yeah. Okay. So this shader is used for the sky in the game. Let me click on. So this is a work in progress for a little visual upgrade. If I dezoom, this is what the shader is applied on. Okay. Yeah. Okay. So if I move
in the sphere.
Yeah, it's applied on the sphere, right? It's so where the camera is always placed inside the sphere. That's why we call it a skybox or sky sphere, whatever. uh, Basically, if I move, it's not really interactive right now, but basically, the shader takes care of what, of making the sky more dark or more transparent. On the top and more brighter and yellower on the horizon. There's other shaders for the ocean, other shaders for everything, but this particular shader is for the sphere right here.
Do shaders have resolution, like you know, like a normal texture or something like that, or it's an infinite number of calculation they can make?
Textures have a resolution. Textures are just, you know, images. They have a resolution, but shaders are applied per pixel, so it's all on the resolution of your game. If your game is stretched on the entirety of your screen, you know, 1920 by 1080, then it's gonna cost a certain amount. If this is why, like, if your game doesn't run smoothly, then we recommend, you know, scaling it down. So that there's less pixels to calculate, right? You can also do geometry textures, but that's a totally other story.
Let's keep that for another time, maybe.
Yeah. Anyway, like that's a really basic overview of what shaders do. For example, this shader does the same thing I mentioned, like with the world normal. It also interpolates between UV coordinates. UV coordinates, they're so for a mesh, there's X, Y, and Z coordinates. This is like for every point of the geometry, what their position is in the world. UV coordinates are for every vertex of the mesh, is where they are in the texture. So they look up. So that's how you texture objects. I use the UV coordinates to determine where the point. So the sky shader has like a fake sun in it. You know, this is what the sun, where's the sun is right now, but it could be anywhere. On this is how I make the sun move? Yeah, exactly. This is how I make the sun move. I actually make the sphere point at a real object that moves around the universe of the game. And if so basically I make the UV coordinates point at that spot, and then I ask the shader to interpolate the brightness depending on how close it is to that point. Okay. And then I add a whole lot of different channels. Like this is I don't remember what's. Oh, there you go. This is the channel that takes care of the sun. There's another channel that takes care of the normal direction. That's the one right here. There's another channel that takes care of the horizon color. It's this one over here, I think, minus that one. Anyway, so I'll add these color values at the end, and I put it in the emission. Emission is it's not a surface, it's not specular, it's not normal, it's what the light that the material produces by itself. It's not light bouncing off the object. So anyway, it's an actually pretty simple shader in terms of shading. Yeah, but since it's simple, it allows me to add a lot of subtlety, you know, of things that react differently to the lighting. So it's an upgrade from the actual material that is in the game right now. So yeah.
Is there documentation where you can learn about shading in the tool for Unity? Is there a community online or something like that?
Yeah, absolutely. There's not a lot of documentation from Unity itself. but Shader Force it has a very good documentation. Let me open it right here. It actually explains everything in really good detail. But yeah, I mean, you still need a very basic knowledge of graphics programming. So I recommend trying out the tool because it's actually pretty cheap. Well, it's not cheap in terms of asset store, but in terms of any software, it's really cheap. I mean, it's less than $100, I think. Yeah, it's just an excellent tool. Yeah.
So that's about it, and we'll talk to you soon.
Okay, cool.
So just before we go, we have a surprise for you, a new thing we have set up here in the studio. We are a fan of video game, indie games, and a few times ago we did a Let's Play session with some people of the studio, myself included. I suck at it. We played Magicite. It's a great game, but it's a very hard game. So here's the highlight of this Let's Play we did.
No!
Oh. That bee is humping you hard. Okay.
Wow.
Poo in my face.
You went away with my corpse.
Till we find a big net.
Oh,
okay.
God.
Yeah,
Like this one.
that's a good idea.
Go.
Is they're pushing? They pushed me out.
In the Magicite universe, there's just randomly floating blocks in the forest.
The complete session of the Let's Play will be available online. It's a little perk, a little something we have set up for you, so it's not something we'll do every week. Remember, this is a platform video for you. If you want to see something to appear on the show, you can comment on the section below, on YouTube, on Twitter, and Facebook. We'll take all comments, so see you next time.